So we're moving with chapter 5. We've done forces in one direction. That's what the last chapter was about. Chapter 4 was all about forces in one dimension or one direction, okay? Either horizontal or either vertical. So now chapter 5 is now moving on to forces in two dimensions, okay? So we're looking at forces that are being pulled at an angle, or you have multiple forces that you need to add together to find that net force, things like that, okay? So we're looking at forces now that are in two different dimensions. That's what chapter 5 is all about. Okay, in order to start working with these, we need to take a little refresher as to what a vector is. Can anyone tell me what a vector? Vectors have to have two things. David, you were there. What are they? They have to have magnitude and direction. Exactly. Okay, they have to have a magnitude and direction. Do you know what a vector is overall? What would be its overall job? Yeah, Teresa.
Does it represent motion?
Yeah, exactly. Vectors are representation of motion. That's exactly right. Okay, so vectors are representations of motion. Can you think of different types of vectors we've worked with thus far? Yeah, a free body diagram has vector representations. Very good. We've also worked with displacement vectors. Does anyone remember what the term displacement means? Say that louder.
How far it is from its starting point?
Yeah, that's exactly right. Okay, how far it is from its starting point. That's a displacement. Really good. So how far it ends up from the starting point. If you already have these in your notes, that's fine. I'm just doing a refresher on them. Okay, how far it ends up from your starting point. That's a displacement. Okay, can you think of any other types of vectors that we've looked at? We've done displacement, we've done force vectors. What other things do we know have to have a magnitude and a direction? Velocity and acceleration. Those are also two other types of vectors that we've looked at thus far. Okay, so we've talked about displacement, velocity, acceleration, and forces as being types of vectors. All right? So we reviewed last class how to find Pythagorean theorem, how to solve with trig functions, all that kind of stuff, right? Do you guys feel pretty good about that, or do we need to go over more examples of that?
I'm feeling great.
Feeling great. Okay. So now we're going to look at taking these force vectors that are in multiple dimensions and breaking them down into what we call components. Okay? So a component, we're going to start breaking these down into components, and these are either the horizontal or vertical kind of portion of a vector. Okay, so vectors that we look at have to be the sum of some vertical portion and some horizontal portion. Okay, so vectors that, if I say I have a vector that is 80 newtons and it's at a degree of 31 from the horizontal, that means this resultant vector right here has to be a sum of this horizontal and this vertical vector. Okay, and we're going to learn how to solve for those, and we're going to learn how to find them and combine them with lots of other vectors. All right, so we're going to start learning how to break down into horizontal and vertical components. Before we can do that, we need to take a quick review on our cardinal directions. Okay, because we're going to start dealing with cardinal directions a lot. Okay, so here is my coordinate system. What is this label here?
North.
North, good. And as I go clockwise around, east. Good. What's this? South. And this here? West. Very good. Okay. So what if I draw a vector right here, and I'll give this just a random value here, and I want to find this angle is 31 degrees. Okay? What direction would I say that this angle is going at, or this force vector is traveling at? What angle would this be? Northeast. Good. North, and we want to call this north of east. Okay, and the reason we do that is because we have these vector components. First we're moving east, and then we're moving north. Okay, and we work that backwards, and we say north of east. Okay, so these little green lines here are our vector components. And we'll call this x, and we'd call this one y. Why do you think I chose to call this x and this one y? X and y axes, exactly. So we call all vertical components something with a y, and we call all horizontal components with the x. Okay, does that part make sense? So let's do just a quick, easy example here. Am I okay to clear this screen? Okay. If I have, I'm just going to draw my coordinate system. If I have a vector that travels, let's say 20 kilometers north, and then, I don't want to do AD, let's say 30 kilometers east. Okay, so this is kilometers, and it's in the north direction. I went straight north and straight east. So these are my vectors. I added them tail to tip. Okay, do you remember doing this before? Adding vectors tail to tip? We touched on this very briefly. Now we need to really start taking it into effect, okay? So let's say this person walked 20 kilometers north and then walked 30 kilometers east. This is what their journey would look like. Okay, we now need to find their displacement, their total displacement. And the way we do that is we find this vector right here. This would be like our resultant vector. Okay, so if I ask, how far is this person from home, this is what I'm trying to find. I'm trying to find this resultant vector. So how do I find that value? Yeah, Pythagorean theorem. So v sub r squared equals 20 squared plus 30 squared. And what'd you get for v sub r then? 36.5? 05, okay. And the units there are kilometers. So if we're looking for a vector here, do we have both a magnitude and a direction? We do? No. Okay, we have our magnitude. This is the size of our vector. Now we need to find that angle in which they walk at. Okay, so we want to find this angle here. How do we go about doing that? Do you know which one? If we have the opposite side and we have the adjacent side, we use tangent. Okay, so in order to find the angle, we use second tangent of opposite, which is 30, over adjacent, which is 20. And we find that angle. You need to make sure that your calculator is in degrees, not radians.
That would be in mode, right?
Yeah, if you go to mode, you'll see if it's in which one, Sam. All right, who got 56.3 for their angle? Good. Okay, can you tell me what direction then this angle would be? East of north. Okay, and I'm going to show you why. This is how we write our final answer. 36.05 kilometers at 56.3 degrees east of north. Okay, and I'm going to show you how we determine that east of north angle or direction. But this is how we would present our final answer. So if we ask, how far away is this person from where they started? This is the answer that you would give. Okay, so that distance and a direction, magnitude and a direction. So let's look at how we found the north of east part of this. Okay. So this is how we determine why that was east of north. Okay, we had a person that went north and then they traveled east. Okay, so to find that resultant vector, I went north first and then I went east. So I went north and then I opened the door to the east to find this angle. So then I work backwards and I say it's east of north.
You always start at the origin.
You always start at the origin. That's exactly right. You have to start at the origin, and then you can figure out which. You can go. I could go the other way too. I could say I went east first, and then I went north first, and then my angle would be north of east. Okay. You can choose to do either angle. Okay. That will give you the same position in the coordinate or in the quadrant. No matter what you do, you just have to label it correctly. Okay. So let's say that I have an angle. I'm going to travel here, and then I'm going to travel here, and my resultant looks like this. Okay? If I wanted to find this angle, what would it be labeled? I go west, and then I go south. So it says south of west. Okay? And you can choose to get to this end point, whether you go west then south, or you go south then west. Okay? If I went this way, then I'd be finding this angle right in here, and what would that be called?
West to south.
Exactly, west of south. Okay, so this angle right in here would be west of south. Okay, so you make your way to that endpoint from the origin, and then you read it backwards. Does that part make sense? Kinda? So in order to do this graphically, which we're going to do first, we need to determine a scale. Okay, so we can't measure 10 kilometers with this little ruler, right? You need to make a scale. So the scale that I usually typically choose is 10 kilometers, or 10 meters in this case, because we're in meters dealing here. 10 meters would equal 1 centimeter. That would be the scale I would choose. You could choose 10 meters equals a centimeter, 20 meters equals a centimeter. You can choose whatever scale you'd like. Okay, but choose something that will fit onto your So I'm going to draw it up here on mine as well. This is just a representation of graphical approach. And I'm going to use my 10 meters equals 1 centimeter. So mine's not going to be really exact because it's a little hard to do this on the iPad, but I'm going to try.
And then you measure from point A to the final point.
Exactly. Then you're going to measure from your origin to the tip of that final arrow. Oh, I don't have enough room on mine to draw it all the way. Okay, so if you do your full version, it's going to look better than mine because I'm not going to be able to draw it all the way to scale. I'm going to draw a rough sketch of mine because I don't have enough room.
I came out with approximately 60 meters. Is that about right?
I'm not sure.
Do you have to measure it out?
Mm-hmm. Okay, so you have your resultant drawn. Now you measure your resultant and see what you get.
Like how many centimeters?
And then you convert that to your scale.
60.
So measure that and see about roughly what you get. we're going to find a way to find this resultant mathematically now. Okay, so I'm going to kind of get rid of my picture here so we have some room to work.
So when we do this, like, we'll have to do it both ways, or we can do it
Nope.
the other way?
You can do it whatever way you want. You can do it whatever way you want. So in order to do this mathematically, we're going to add up. We want to find this resultant vector, right? That's what our goal is, to find a resultant. And it kind of looked like that. It was at an angle, right? That's what we're trying to find. But that resultant has to be made from a triangle of some point. We want to find these x and these y values in order to make that triangle so that we can find this resultant length. If you look back at your picture, your resultant is at an angle, right? That angle has to be made from some vertical and some horizontal component. Okay, so we're going to find that. So what we do here is we add up all of the verticals and all of the horizontals. Okay, so let's think about vertical. I'm going to call this y. Okay, why do you think we're calling the vertical components y's? Y-axis is vertical. Okay, that's the reason. So tell me which of these is this vector right here, vertical or horizontal? Vertical. And is it going up or down? Down. So I'm going to say this is a negative 10. Negative 10. So what about this 30? Is it going vertical or horizontal? Horizontal, and it's negative, exactly. Negative 30. Okay. So what about the 90? Horizontal or vertical? Vertical, and it's negative because it's going down. What about our 50 meters east? Horizontal, and it's positive. So it goes in the horizontal. What about this last one over here? Positive, vertical. Very good. Okay, so what we did is we broke these vectors down into components, and now we're going to find our resultant vector. So this is going to come up to be positive 60. Oh, I'm sorry, negative 60. And this will become positive 20. So this is our y component, and this is our x component of our resultant vector. So these are the things that we're going to use to make our new triangle, our resultant triangle. So we'll start at our origin here. I'll draw my new coordinate system. Okay, we're going to start at our origin, and we'll start with our y component first. We'll go down 60, and we'll go positive 20, which is in this direction, correct? You don't have to draw it to scale because we're solving it mathematically now. Okay? Oh.
Now we have to do the Pythagorean theorem thing?
Yeah, exactly. So I'm going to draw my resultant here. Does this resultant look like it's at the same angle and look like it's in the same direction as our drawn one? It should be, right? It should be the exact same magnitude and direction as our graphical version of it. So let's find Pythagorean theorem and find this v sub r. Use Pythagorean theorem here. Yeah, Evan?
It'd be fun if you drew it like the same as the graphical one, right? Like since the angle is here, draw this is your 20, this is your 60.
Mm-hmm.
So I mean, could you go like that since that's how it looked?
Pretty close. Okay, so 63.2 meters. Now what we do is we find the angle. We've got to find also the magnitude. This is the magnitude. We've got to find the direction. So we find this angle right here. And we do that using what trig function?
We don't have options.
We have our opposite and we have our adjacent.
Wait, why are we finding that angle?
Because this resultant vector has to have a magnitude and a direction.
How do I know we can equal the time? Is it the one in the...
The one inside the triangle. Do the one inside the triangle. Okay, the one from the origin.
Okay, there you go.
Yes. Find the angle from the origin.
We have opposite and adjacent.
So we enter second tangent of opposite over adjacent. 18.5? 18.4. And what direction is that? 18.4 degrees at east of south. Perfect, perfect, perfect.
So, it's 63.
So this problem we're going to solve purely mathematically. Okay, we'll draw the diagram, but we're going to do it mathematically. We don't have to worry about doing it graphically because we can't make that 45-degree turn very well without a protractor and a whole bunch of other stuff. Okay, so we're going to draw a rough diagram of it, then we're going to do it completely mathematically. Okay, so here's what our diagram of it looks like. If we draw our coordinate system right here. This person walks 4.5 kilometers in one direction. Let's just say she walks east. Then she makes a 45-degree turn to the right. Okay, so she's walking, and she makes a 45-degree turn to the right. She's going to go somewhere down in this direction. Okay, so she's going to end up somewhere over here. So the resultant, I'll draw the resultant here, is from the origin to the finishing point.
So it doesn't matter which way you go on the graph.
For our resultant, can we just use Pythagorean theorem here? No. Why not? Why can't we? Yeah, this is not a right triangle. Oh. Okay, this is not a right triangle, so that doesn't work. What we do here is we're going to break each of these vectors down into components. We're going to break each of them down into horizontal and vertical, and then we'll build a new triangle to solve for this resultant vector right here. Okay? So let's look at how we label these vectors. We'll call this v sub 1 because it's our first vector. We'll call this v sub 2, and we'll call this v sub r. So if we're going to break these components, or these vectors into components, let's look first at the v sub 1 vector. Does this vector have both horizontal and vertical components? No. What components does it have? Only horizontal. Okay, it has only horizontal components. So I broke these down into an x and a y component for a v sub 1. Since we know it only has horizontal components, what's that mean the value of v sub 1x has to be? Yeah, 4.5. Okay, because this is our 4.5 in one direction. What does the v sub 1y then have to be? 0. Exactly. Okay, because it has no vertical, nothing going in the vertical direction. Okay, this right here, this vector, has nothing going for it in the vertical direction. So v sub 1y, y means vertical. It has nothing, no motion or no indication in the vertical direction at all, so that's just 0. We've only been dealing with v sub 1, right? So thus far, okay? Now we're going to start dealing with v sub 2, which is our vector that is at an angle. Okay, so v sub 2 looks like this, right? We have a vector that starts from here and it goes down at a 45-degree angle. Okay, so here's our 45 degrees. Then we're going to make a little triangle here. We know that the hypotenuse of the triangle is 6.4 because it says she travels 6.4 meters in that direction. So what do you think these labels might be, like right here and right here? Do you have any idea what I might label those?
V-I-X,
X and Y.
V2X, V2Y.
Yes, exactly. Okay, so this is going to be called, this top one will be called v sub 2. What do you think?
X.
V sub 2x. Very good, because it's going horizontal. This will be called v sub 2y. Very good. So now we just solve for those components. That's it. We solve for those components using our trig function. That's why we need to be good at those trig functions. So to solve for v sub 2x, what trig function should we use? We have our angle.
Can't you use the law of sine?
I don't know.
We have our angle and we have our hypotenuse.
Oh.
Cosine. Our cosine is the 45. Yeah, sorry, it's kind of hard to see. Okay, so we're going to say cosine of 45 equals our adjacent side, which is v sub 2x, over our hypotenuse, which is 6.4. So then we just take 6.4 times cosine 45 and we get that value. 4.5. Okay, so that's how many, that's that x component or that horizontal component of this resultant or this 6.4 kilometer vector. That's the x component. So now let's find our y component, v sub 2y. We're going to say sine 45 equals v sub 2y over 6.4.
Same thing.
Yes, it should equal the same thing because it's a 45-degree angle. Okay, so what about this y component? Is it going vertical or is it going horizontal? Or I mean, is it going up or is it going down? Down. So that means this 4.5 should be negative. The negative is because this y component right here,
Where's your
What is that equal to V2y?
v sub 2y is negative 4.5 because in order to get there, we went over, which is positive direction, and then we went down, which is negative direction. So v sub 2y is negative. So now that we have x and y components for both of our vectors, we add them together. Okay, so v sub 1x plus v sub 2x, which is 4.5, plus 4.5. That gives us 9. That's going to be our v sub r x. That's the x component of our resultant vector. Now we add our v sub 1y plus v sub 2y. We have the x and the y components of both of our vectors. We're just adding those x's together and we're adding the y's together. So our v sub 1y is what? 0. Our v sub 2y is negative 4.5. So that means our resultant y component equals negative 4.5. Okay? We're almost done. We're almost there. So can I get rid of some of this work so I have more room? Okay. Okay, let's keep in mind our overall goal here. We want to find this length. So now we have our resultant components right here. This equals v sub r, our resultant, that equals the y component of it. So I'm going to redraw here my coordinate system. And I'm going to draw the components of this vector that I have. I'm going to go 9 units to the right because that's what this tells me right here. V sub rx means I need to go 9 units to the right. I need to go up or down 4.5 units. Down. And here is my resultant vector. And now I have a right triangle which I can solve it for. Okay? So this vector right here and this vector are the same. We just found... What?
So we did that other work so we could make it a right triangle?
Exactly. That's exactly right. We did all that work so that we could make it a right triangle. Okay, so now let's find f v sub r. Use Pythagorean theorem. 10.06. And we need to find this angle right here.
So we do it in honor.
I would do tangent because you want to use the things you're given, not the things you, not the like secondary thing that you solved for. So I would do tangent 4.5 over 9.
Why doesn't it say negative?
It's 26.6.
It won't make a difference on the angle. 26.6.
Yes.
And what direction is this angle going?
South of east.
Exactly, south of east. Oh, I'm sorry, that's kind of hard to see. It says south of east. And drives 22 kilometers in a northerly direction. She then drives, I think it says drives, in a direction 60 degrees south of east for 47 kilometers. What is her displacement from the post office? So, this is her starting point. The origin is her starting point. She's going to drive 22 kilometers north. And then she's going to turn 60 degrees south of east. So we'll kind of make a new little origin here. South of east.
It goes right.
Okay, so the south of east would be right here. This you could kind of think of it as a new little starting point here, a new origin, and this would be your new x axes, and like that. If you want to think of it like that. Okay, so can we just take our resultant, which would go from the origin to the finishing point? Can we just take it and form a triangle here? No, this is not a triangle that works for us. So we need to do these vectors separately. Okay, just like we did in the last problem. Okay, yes, these are long problems, but you have to get over it. Okay, that's the bottom line, okay?
Is this one different than last time?
Nope, we're doing the same process. Exact same process. Sorry.
Okay, so what triangle are we trying to figure out now?
We're trying to figure out like a triangle that looks with this green one, with a green resultant. Let's say that the triangle will look like this with the orange. That's what we're kind of trying to get to figure out here. All right, we're trying to find this resultant right here, V sub r.
Wait, then I thought we all used to use this triangle that 60 was.
We're going to do that. We're going to do it separately. I'll show you.
I'm confused on the stuff.
We've labeled our first vector as the 22 kilometers. We labeled our second as our 47 at 60 degrees, okay? So we're going to break these down separately. V sub 1x and V sub 2x. V sub 1x
0.
is 0, exactly. Because V sub 1 only is going in the north direction, so it has no horizontal component to it at all. Okay?
Wait, why is it 0?
It's 0 because this 22 is only going north, so it doesn't have any horizontal component to it at all. And the 22 kilometers north is our first vector. V sub, oh, I'm sorry, I didn't mean to label it like that.
I think that was a Y. It's just,
I'm sorry, this should be V sub 1 y. I'm sorry, I didn't mean to confuse you like that. So V sub 1 y we know is 22. Okay, that's my fault. Okay, so we're done with our first vector. Let's move on to V sub 2. Okay, and this is our V sub 2 vector. It starts up here, and it goes 47 kilometers at a 60-degree angle. So all I did was move that vector from our original diagram over here, and I made a triangle out of it so that we can find those components. This will be V sub 2x, and this will be V sub 2y. All right.
It doesn't matter which side you do first.
We're going to use our trig functions, and it doesn't matter at all what side you do first, because you're going to need to find both. So go ahead and do your trig functions to find that, and give me those values for them. So for V sub 2x, you're going to use what? cosine. For v sub 2y, you're going to use sine.
40.
That's right. Okay, so we have our components here, but 23.5, v sub 2x we know is positive. The 40.7 needs to be negative because it's going downward over here. Okay, so that's a negative component. All right, so now let's add these components together and we're going to get our resultant. So v sub 1x plus v sub 2x is going to equal 0 plus 23.5, which gives us 23.5. Okay, and that's our v sub r x component. Okay, so that's our resultant vector x component of that. We're going to do the same thing for the y's. So our y vector or y component for the first is 22. Our y component for the second is negative 40.7. So tell me what we get for that answer. Negative 18.7, exactly. Okay. So now we have our components of our resultant triangle. We're almost done. So now we're going to take, I'm going to just redraw this coordinate system. And we're going to go x first. You could go x first or you could go y first. It doesn't matter. Okay, I just typically go x first. Okay, so I'll go 23.5 this way. And then I'm going to go up or down 18.7? Down. Down. And here's my resultant. So look, are these two, this vector and this vector, do they look like they're at the same angle? Do they look like they're about the same magnitude? Yeah, they should be. They should be the exact same. All we did was formulate it so that we have a right triangle to deal with. Okay? Because there's no way we can find this magnitude and direction without a right triangle. We just can't do it. Okay, so that's why we have to solve for this right triangle portion of it. So you do Pythagorean theorem and find the angle just like normal. Okay, so we got 30 point anything? Okay, we'll just call it 30. So that the magnitude of that vector is 30. The angle then is what? How do you find the angle? Using what trig function? Second tangent, exactly.
So you're using negative
Whenever you want to find an angle, you got to use the second button.
Okay.
Okay. So what angle did you get? 38.5 degrees. What? South of east, exactly. Okay, that's it. You did it.